Okay, so now that we've gone over some of the homework from 1.4, I would like to finish our notes from section 1.5. All right, we talked last class about what is meant by a graph of a function. You did do some work on a domain and range worksheet, which we will go over when I return with you next class. We talked about what is the domain and range of a function. We talked about the vertical line test as a way of determining whether a graph is the graph of a function or not. We talked about how to find the zeros of a function. All right. And we also talked about what it means for a function to be increasing, decreasing, or constant. And we talked about how to find relative max and min by looking at a graph. But I don't think that we talked about how to find relative extrema or zeros on the TI Inspire. So let's try this example. We're going to graph f of x equaling, excuse me, negative 2x cubed plus 3x minus 1. And so on our graphing calculators, negative 2x cubed plus 3x minus 1. Let's type that in. I'm on a graphs page. Negative 2x cubed, so I've got to do x raised to the third. But I do want to kind of give you a little heads up that right now I'm still locked into the exponent, so I need to get out of the exponent. So I'm going to do a right click. Now I can type in the rest of what I want, which is plus 3x minus 1, because otherwise the plus 3x minus 1 would be part of that exponent. Okay, so there it is, and when I graph it, the graph looks something like this. All right, and let's say we're trying to find the relative minimum, which is going to be this point right about here, and the relative maximum, which is going to be this point right about here. We can do this very easily with our calculator by going to Menu, Analyze Graph, and Minimum. And here's that minimum right there, but it's asking for a lower bound, so we just need to go somewhere to the left of that with the little pointer and click, and now it's asking for an upper bound, so we got to go somewhere to the right of that and click, and it is highlighted that this is a minimum value, negative 0.707 comma negative 2.41. Now technically we would say that the minimum occurs at that ordered pair, but the minimum itself, the relative minimum, is the negative 2.41. So over here, let's say that there is a relative minimum at negative 0.707 comma negative 2.41, and we would say that the minimum is negative 2.41, just that y coordinate. All right, going back to the graph, if we want to find the relative maximum, we're going to do this again. We'll go Menu, Analyze Graph, Maximum. Again, it's asking for a lower bound, so I'm going to go slightly to the left of my maximum and click. And I want to go slightly to the right for the upper bound and click. That grayed out area is your search zone. And I'm getting 0.707, 0.414. So we have a relative maximum at the ordered pair 0.707, comma 0.414, and that means that the maximum is 0.414. I should say the relative minimum, the relative maximum. Okay, and then also to find, this was also asking for the zeros of the function, and so to find the zeros, it looks like there are 3 of them, one right there, one right about there, and one right here. Let's just find one of them. You can find the other 2. So if we go to Menu, Analyze Graph, and 0, if we want to find this first one to the left, go a little bit to the left of the 0, go a little bit to the right of the 0. Calculator has found one for you at negative 1.37. So that's one of the zeros of the function. All right, and I'll let you find the other 2. Okay, at this point, I want to switch gears and talk about the average rate of change. Little recall here, you know that the slope of a line can be interpreted as a rate of change, like dollars per hour or feet per mile, something like that. For a nonlinear graph, the average rate of change between any 2 points x1, comma, f of x1 and x2, comma, f of x2 would be considered the average rate of change. All right, so the line through the 2 points is called a secant line. So let's get a visual of what's happening here. If we have a graph that looks something like this, and we know that there's an ordered pair right here, which is, let's say, x1, comma, f of x1, and we know we have a point, let's say, right here, that is x2, comma, f of x2. First of all, this x1, that is the x value right here, so that's x1, and here, this x value is going to be x2, whereas the height of this ordered pair, that is your f of x1, and the height here is your f of x2. All right, so the average rate of change is going to be the secant line that goes between those 2 points. So that was pretty bad. Let me try that again. So secant line, maybe something like this, that would be the secant line. And basically, if we want the slope of that secant line, that's going to be the average rate of change between one point and the other. So you know that the slope of a line is y2 minus y1 over x2 minus x1, but in this case the y2 would be f of x2, f of x sub 2, and y1 would be f of x sub 1. So that's why we have a formula for the average rate of change is going to be, instead of y2 minus y1, it is f of x2 minus f of x1 over x2 minus x1. That would be the rate of change of the function from x1 to x2. And you are usually given those x values. All right, so let's take a look at this example. It says find the average rate of change of the function f of x equaling x squared minus 2x from x1 equaling 0 to x2 equaling 1. All right, so we can just use our formula that we have right above here. That's this formula here. And we want f of x2 minus f of x1 over x2 minus x1. All right, so we need f of x2. In this case, that would be x2 is 1, so that means I really want f of 1 minus f of 0, because that's my x2, right? That is x2. Oops, I'm sorry, that was x1. So right here, this is your x1, right? Right here, this value is your x2, all right? And we're dividing by, formula says divide by x2 minus x1. So that would be 1 minus 0. So what is f of 1? F of 1 is equal to 1 squared minus 2 times 1. That's 1 minus 2. I'm getting negative 1. So right here, the f of 1 is equal to negative 1. And then the f of 0 is 0 squared minus 2 times 0, which is 0. That is going to be your f of 0. So it looks like we really want negative 1, negative 1 minus 0 over 1 minus 0. So that's negative 1 over 1, which is negative 1. So the average rate of change is negative 1. Okay, and just to kind of show what this looks like on a graph, if we were to draw a graph here, let's see how long it will take me to find graph paper. Okay, so if we were going to graph this function, right, which is f of x equaling x squared minus 2x, okay, all right, you know we could factor out an x, and so this would be x times x minus 2. If I wanted to find the zeros of this function, I would just set the whole function equal to 0, set each of these parts equal to 0 because it's already factored. I would get zeros at 0 and at 2. So if I plot those, if I plot those, I would have 0 here, 2 here. The graph would be somewhat looking like this, right? It's opening up, it's a parabola, and it would be going through those two x-intercepts. And so if they're asking for the average rate of change on this graph between 0 and 1, all right, that's basically saying take the point where it's 0, which is right here, and the point where it is 1, which we already know f of 1 is equal to negative 1, which means I guess I didn't draw my graph very well. So let me redraw my graph because it is supposed to go through 1, negative 1. So my graph would look something like this, and I'm looking for the secant line, and the secant line would be line that goes through 0, 0, and 1, negative 1. So something like this. All right, and that slope of that line, as we can see, it's going through 0, 0, and 1, negative 1. The slope is equal to negative 1. So that does make sense that the slope, I hope it makes sense, that the slope is equal to negative 1. All right, and we found that slope of the secant line, and that's the average rate of change of the function between x equaling 0 and x equaling 1. All right. Okay, so there is an example here, the distance s in feet of a moving car from a stoplight is given by s of t equaling 30 times t to the 3/4, and you are asked to find the average speed of the car from t1 equaling 0 to t2 equaling 5 seconds. All right, so this car is, it's parked at a stoplight, and it's going to start moving again from the stoplight after the light turns green. And so, if I plug in 0 at time t equals 0, 0 to 3/4 is 0, times 30 is 0 still. But we want to find the average change, so we're going to do s of 5 minus s of 0 over 5 minus 0. All right, and so in this case, s of 5, if we're working on just this part right here, s of 5 is equal to 30 times 5 raised to the 3/4 power. This is a real world problem, so let's get a decimal approximation for that. 30 times 5 to the 3/4. I'll just pull up my little scratch pad here. I want 30 times 5 raised to the quantity 3/4, close parentheses, like that. I am getting, and I'm going to do Control Enter to get a decimal approximation. I'm getting about 100.3 as my answer. So if that's 100.3, okay, and then I want s of 0, which we already said is 0. So this part right here is equal to 0. So I get 100.3 minus 0 over 5 minus 0. And so that's going to be right about 20, I think.
Please call extension 1100.
So if I do that answer and I divide that by 5, yeah, I get about 20.06, something like that. So in terms of this real life problem, Since this is, approximately 20.06, that is going to be what units? Well, in this case, it's going to be feet per second would be the average rate of change, because this was the change in their position, right? The distance that they traveled, and this was the change in the time. So feet per second. All right, and let's look at this next concept. That's the whole idea with even versus odd. A function is even if its graph is symmetric with respect to the y-axis. So any function that has symmetry with respect to the y-axis is called an even function. So just as an example, if I give you the graph y equaling x squared, that graph, as you know, looks like a parabola, bowl shape, vertex at 0, 0, symmetry with respect to the y-axis. So we would say that y equals x squared, or maybe more precisely, since we're talking about functions, I should say f of x equaling x squared. That's going to be an even function. Okay. A function is odd if its graph is symmetric with respect to the origin. Remember, symmetry with respect to the origin means it's going to pass a 180-degree spin test. So, for example, if I sketch a graph that looks like this, all right, that graph is really, I'm just going to give this away, this is the graph of f of x equaling x squared. And does this pass the 180-degree spin test? Well, if I spin this graph 180 degrees, I will get right back to where I started from. So it is symmetric with respect to the origin, and we would call this an odd function. Is it a coincidence that the exponent here is odd and the exponent here was even? No, that's not a coincidence. So yeah, x squared is going to be an even function, x cubed is going to be an odd function, x to the fourth is going to be even, and so on. But there's lots of functions where you don't have that little clue. So in that case, you would need to use a little test. So here's the test to see whether a function is even. If f of opposite of x equals f of x, then the function is even. So let's test this function. Let's say f of x equals the absolute value of x. Is that going to be an even function? Well, if I test it by plugging in negative x wherever I see an x, that means I'm really taking the absolute value of negative x. And that is the same as just absolute value of x. So it is true then that f of negative x is equal to f of x. They are the same. So that means that this is an even function. All right. The test to find out whether a function is odd is going to be f of negative x. If you plug in negative x into the function, do you get the opposite of the function back again? All right. So to see if that is the case, let's just try my example. Well, let's try this one. Let's say f of x equals x minus 4x cubed. All right, let's test that out by plugging in negative x. So if I want to find f of negative x, that's going to be opposite of x minus 4 times opposite of x quantity cubed. Okay, notice that opposite of x, that's the same as, I can write it this way, opposite of x. And then I've got minus 4 times negative x times negative x times negative x. But that is just going to be equal to negative x minus 4 times opposite of x cubed. So that is going to be negative x plus 4x cubed. That is just the opposite of what we had. So f of negative x is really the opposite of our original function, because we get negative x plus 4x cubed. So they're just opposites. So that makes this function an odd function. And if we were going to graph it, it would pass the 180-degree spin test because it's an odd function. Okay, so I think for our purposes right now, I'm going to stop this lesson, and I know that you're going to have some work to do for me in class and some homework. So have a good weekend, and we'll see you on Monday, and that's it.